This two-part question initially looks a bit complicated. It talks about minimums and tangents, but actually when you break it down, it is fairly straightforward in both parts. So let's look at the question here. It says that the diagram shows a sketch of part of the curve with the equation y equals x squared minus p over x, where p is a positive constant. So look at the graph. We have a curve that comes down here, goes through t and comes up. We also have this line here. Looks like it's a mistake, like it shouldn't be there, but it is actually technically part of the curve, part of the function. The graph is not drawn to scale, but it gives you an idea of what this would look like. Now it says at the bottom here, for all values of p, the curve is exactly one turning point, and this turning point is a minimum shown as the point t on the sketch. So the turning point is here. That's one here, okay, it's marked as t. And it says for the curve where the x coordinate of t is minus 3. So we know, and I'm going to mark it on, and this is the sort of thing you want to do, the x coordinate for t, so let's be down here, would be minus 3. And it asks you to find the value of p. So whenever you've got a question like this and it talks about minimums down here, then what you will need to do is think about differentiation. So look at my function here. I got y equals x squared minus p over x. And this I'm going to have to differentiate. So to differentiate it easily, what I need to do is to write it in index form. So I'm just going to rewrite it as y equals x squared minus p x to the minus 1. Once you have it in this form, it's a lot easier then to actually differentiate. So we're going to do dy by dx, and that will be the power comes down to the front on the x squared, so it's 2x, take 1 off the power of 2, so it just becomes 2x. And then we look at the next part, the minus 1 comes down to the front and multiplies by the minus p. P is just a number, so that gives me plus p x, and take 1 off the power, so it becomes minus 2. And then I'm going to rewrite that just as I had it in index form before, and now I just want to write it as a normal equation. So it's 2x plus p over x squared. The reason I do that is it just makes more sense in my head when I'm actually looking at it. Now, that's the equation of dy by dx. Remember, when we differentiate, we can actually then calculate the gradient of a tangent at that point. Now, we know this is a minimum, so the gradient will be 0. So I can put 0 equals to 2x plus p over x squared. And reading in the question, it says the x coordinate is minus 3. So I know x is equal to minus 3 at this point. So I can put that into my equation. 0 equals 2 multiplied by minus 3 plus p over minus 3 squared. Let's tidy this up. 2 times minus 3 is minus 6. Plus p over minus 3 squared. It's the minus 3 that is squared, not the 3. Minus 3 times minus 3 is 9. So that's p over 9. I have one equation now here with one unknown, which is p, and p is what I'm trying to find. So I can easily solve this now. Let's multiply through by 9. That keeps 0 on the left-hand side. 0 times 9 is 9. Minus 6 times 9 is minus 54. And that's plus p. So p must equal 54. So to quickly recap, what we did was we took our function, we rewrote it in index form, we differentiated because we were looking for a minimum, and therefore we put it equal to 0 because the gradient is 0. We substituted in the value of x, which is minus 3 at that point, and then we solved our equation to find out the value of p. So let's look at part B, which does look a little bit confusing, but hopefully we can make some sense of this one. It says that the line with the equation y equals k is a tangent to the curve with the equation y equals x squared minus 16 over x. This is a slightly different function to the first part. But what does this statement mean? The equation y equals k is a tangent. Well, just think about that for a second. We know that y equals mx plus c is the standard equation for a straight line. And a tangent is a straight line. And we're told that y equals k. Well, if y equals k, k is a constant, that means mx mustn't exist. It must equal 0. So we must have 0 x's plus k. So therefore, we have a gradient of 0. So we have a turning point. So we have a maximum or minimum. Well, that's fine, because we know if we differentiate and put equal to 0, we have an equation, and then we can solve. So that's what we were going to do. So the question basically leads you, this little stuff on the right here, you don't have to write that down. That's just like a thought bubble in a way. But that's what they want you to identify. So we take our equation, y equals x squared. I'm going to write it in index form, so it's minus 16 to x to the minus 1. That's just the same as my function written above. I'm going to differentiate, so dy by dx is equal to 2x plus 16x to the minus 2. The minus 1 multiplies minus 16 to make it positive 16, and we take 1 away from the minus 1. Now, we know we have a turning point, so we put 0 equals to 2x plus 16x to the minus 2. Let's write that in the sort of standard notation as such. 16 over x squared, like that. And I want to solve, so I'm going to multiply through by x squared. So I'm going to have 0 still on the left-hand side, 2x cubed plus 16. So all I've done there is multiply throughout by x squared. Okay, so let's rearrange and solve. So I'm going to take away 16 from both sides. So minus 16 equals 2x cubed. X cubed then is equal to minus 16 divided by 2, which is minus 8. X will be the cube root of minus 8. Now, you should know that we can cube root a negative number. We can't square root a negative number, but we can cube root. And x will be equal to minus 2, because minus 2 times minus 2 is 4, and 4 times minus 2 is minus 8. Now we know from the equation that y equals x squared minus 16 over x. So we put our value of x into that equation. So we say that y equals minus 2 squared minus 16 over minus 2. So minus 2 squared is 4. Minus 16 over minus 2 is plus 8. And 4 plus 8 is equal to 12. So the value of k, because y is equal to k at that point, k will be equal to 12. The equation of the tangent will be y equals 12. That is a particularly tricky question to interpret, not a particularly tricky question to solve. The key bit is what you were doing up here when you were identifying what is going on, realizing that if the tangent is y equals k, that means we have a line, a horizontal line on our graph, so therefore it must be a gradient of 0. So we can just differentiate, solve, substitute back in, and there we have our solution.